Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video we are going to assemble the back battery cover for Inmoov. Now I'm not going to do the full cover the way it was designed. The way it was designed, you install a 6-volt SLA battery in under the cover, and then you can put a LiPo top based battery pack to run 5-volt like a tablet device in a clip on the back. So this is one that I've pre-assembled for the original build, and this is the bracket for holding a battery pack. Battery saver they call them, or phone saver. But what I intend on doing this time, I'll mount this, which goes on the front here and binds the front top together, and I'll weld these parts together. But what I intend to do this time is mount these two devices on the back and weld them into place. Now those are clips for this style of battery, and they just clip in. These are a 2 amp hour 20 volt lithium ion battery, and I have got 4 amp hour versions of these. They've got a nice little indicator on them to show how much charge is left in them, and I figure I can get 2 of these welded onto the back, and that gives me plenty of power, and I can swap them out one at a time. I mounted switches in the back of the back cover of Fred as I was building it. At the moment they don't do anything, so what I'll do is connect each one to one battery so that I can connect the batteries up. I can turn them on and off independently, so I can run through the charge on one. If I use a couple of heavy duty diodes, 100 amp diodes, I can turn them both on, have it run through the one with the highest power, or just turn one on and then change over, turning on the second one before I turn the first one off, and then I can swap out the battery and keep him running without losing power at all. I probably should put a secondary power source that can charge up off those batteries internally, and I'll probably do that to power the Raspberry Pis. In the short term, let's start putting this together. Now while I was printing this, I did run into a little bit of warping. It started to lift on the edge of the bed on each end. The seam between the two is the bottom, and so the layer lines are through this way. It looks like the layer lines are through this way, but that's an optical delusion. It actually feels quite smooth. There are lines going this way, but there's lines going this way as well. So what I'll do is I'll weld it up and then I'll give it a good sanding, I think. Now for those of you who are wondering, this was printed at 0.12 layer height on a 0.4mm nozzle, and I used a, now what do they call that setting? Horizontal expansion of -0.10 using the Simplify 3D slicer. Okay, so that seems to fit on there quite nicely. So the next task will be to sand up, clean up, and then I can weld on the 2 battery holders. Okay, so this has been sanded, and while it looks rough, this way is that it's actually very smooth. One of the issues when using transparent PLA is it's very difficult to see when the top layers are very smooth because you just see through them. But yeah, that is very smooth and ready to go. Good surface for painting. Now with these two, I've actually done a bit of testing with these connected. And what I found is there's, I don't know if you can see through between them, there is a little bit of a gap between them when they are pressed hard up, the bases are pressed hard up, which is good. Now just to be on the safe side, I did grab a pair of larger batteries and give those a try as well. So these are the larger batteries, the 4 amp hour. The only real difference in the dimension is the depth, which is not a major problem. So again, these can press up and the batteries underneath have some wriggle room, which makes removing them easy. So I can mount these hard up against each other on the back. Now there's 2 versions of this STL file, which I found on Thingiverse, and I will link to it for those who have access to these batteries. These are the Xfinity series that are sold in the Aldi stores in Australia. I believe they're sold in a few other countries under a couple of different other brand names as well, and I'll link those names in the description as well. From my perspective, the 4 amp hour batteries are around about the $30 mark each, and you can buy for around the $30–$35 mark a 2 amp hour battery and a fast charger. Alright, so I think what we'll do is we'll align the top edge of these with the top edge of this flat part. The batteries will protrude a little bit above, that doesn't matter. This cover will clip in. As you saw, it was nice and easy to clip in. And then once we've got these attached, we will then look at painting it all. I think for the purposes of safety, to make sure that there's no chance of the batteries falling off, I'll put at least 1 bolt through. We might even get 2 bolts, but I'll try at least 1 bolt. These are an M5 hole canister, so we'll drill through. I've got some short screws, put some nuts on the back, and then weld. So let's get our screws first. Yeah, it looks like I could have gone one way a little bit more. I might slap these holes. Okay, I think the next thing is to run a couple of welds down the bottom, maybe put an extra screw in through the back here. I have got longer screws that will fit these, but the same size I used just then will work for these ones on the top corners. But I think yeah, this feels like a good spot, so we'll weld across the bottom and then we'll weld across the top. I'll do a surface, like a sub weld in the middle there. Getting into this gap in here is going to be difficult to do, so I think I might have to rely more on the bolts and a little bit of weld. Alright, let's get the drill out of the way for the moment, and we'll get ready to do some welding. Okay, so the next thing I have to do is a little bit of sanding to clean up the edges where I've welded, make sure it's nice and smooth, and then I think a paint job. After that, I need to put in the spade connectors for the battery terminals and run the wires through the back. So I've got to run 2 sets of wires back, and they'll go to the 2 switches. Alright, so I'll continue that after I've done some sanding. Okay, I did install these two spade lugs. They're simply crimped onto these wires. When I installed these, I did have a little bit of a error in as much as I forgot to push record on the video. So I don't actually have video of the installation of these wires. It is actually pretty straightforward and simple. They're just a crimped connection onto the wires. Then I installed the wires, or I poked the wires through, crimped them on, pulled them back, lined them up with the batteries so the batteries will plug on, and hot glued them in. The wires, the largest size I could get at the time. I'm not overly happy with that size. I'd like something about 2, maybe 3 times bigger, but it'll do for now. One of the things I am doing is I'm running a 20-volt system and then using a switch mode power supply to drop it down to the required 6 volt or thereabouts for the servos, and the 5.1 to 5.2 volts for the Raspberry Pis. Because of that, the current coming off the batteries is relatively low by comparison to the low voltage, the 6 volts, and the 5 volt battery, or 5 volt supplies, where the current is much greater. In actual fact, I'm running close to a quarter of the same current. So where a full build of an Inmoov can draw as much as 50 amps at 6 volts, I'm not expecting to see much more than 15 amps tops coming off each of the batteries. The wires are rated for around about the 10 amp mark, which should be enough. It is intermittent load, not a continuous 10 amps. Most of the time I'm seeing less than an amp when I've got it all powered up and he's not moving. Once he starts moving, I'm getting up to 2 or 3 amps at the moment. That's based on what my power supply, which is just out of camera view down here. That's based on what this is showing me at the moment at 20 volts. I've got this 7-inch touchscreen with a Raspberry Pi 3 mounted on the back, and that's to go in here, which will complete his back cover. I'll probably remove the back cover. I'm thinking about welding these joints here and then sanding off this paint job. I'm not happy with this paint job at all. It's a nice gloss, but it bubbled, and so the paint job's not very good at all. So I'll sand that off, weld this up, and then when I've got it all together, paint it again using the new airbrush kit. I'll probably have to repaint this cover here. This is a metallic red. It's not as dark as I would like. I wouldn't mind that one being a bit darker as well, but we'll stick with it for now. So that'll do for this video. I will show one of these batteries installed. So they just clip on like so. I can check the setting or the current charge on the battery without any trouble. One of the advantages of these batteries. So that'll do for this video. In the next video, I'll look at setting up the second Raspberry Pi. That will involve running a network cable from up in the head down. I have this 5-volt network switch, so 10100, which is fine because although it's gigabit up in the head Raspberry Pi with the Raspberry Pi 4, the one on the back of this is only 10100. So I'll mount that in the back plate somewhere, run the network cable down, connect both ends into this. A network cable go from this into this one. I've got room that I can put another Raspberry Pi in there if I choose to do so. And I've got plenty of ports to handle that. This is a USB cable with a micro USB on the end of it. I'll strip that back, pull out the red and black wires, which are the power, connect that to a small switch mode power supply just to run the switch. I have also got a very small key switch, and I'll mount that somewhere on the side, and that will be my control switch for the Raspberry Pis. So the brain power, so to speak, will go through the key switch, and these two switches here will be for the servo power. So that'll do for this video. Don't forget to click on like, subscribe, ring that notification bell so you know when the next video is coming out, and we'll see you in the next video.